Hello everyone. So in today's session we are going to see about the programming concepts. In the previous session we have seen programming, introduction to programming language and introduction to the software. Now we are entering into the ladder logic programming. Fine. So we have seen what is normally open contact, what is normally closed contact and all, right? Just a minute. Yeah. So these are all the components of ladder logic that we have already discussed. What is rails, what is rungs and all. Fine. So now in this session, we are going to see about how normally open contact is working and how normally closed contact is working. How to connect normally open contact and closed contact with the coil. That means output device. Fine. So generally, come to normally open contact first. So it is like a normal switch in our home. Fine. So what normal switch in our home? If you turn on, your light or fan will be on. If you turn off, your light or fan will be off. The corresponding switch of light and the corresponding switch of fan you need to turn on a lamp or fan. Correct. So like that, normally open contact control is in your hand. That means unless or until you press, it will not give the supply. Okay. So I'll take a software help to explain this concept so that you can understand better. Fine. Okay. I'll start sharing the software. Yeah. So this is my software environment, right? So this is our normally open contact, correct? So I'm going to use this. I'm going to use only one. Fine. So whenever you are using this, it is asking question mark. So what address we need to put in Siemens? It is I0.0, correct? So you are putting I0.0. This is a normally open contact. Fine. So I'm connecting. You should not leave a rung without connecting output. It will be giving the error. For example, see, if I go for online, what it is telling, a coil or assign is required. Okay. So we need to connect some block or coil with the input. Fine. So to study this normally open contact, I am going to connect one more output here, one output here, and that address is Q0.0. Got it? So this is normally open contact. I'm connecting with the output. Fine. Shall we see the normally open contact, how it is working? So imagine a truth table for this. We are having one input and this is output. Fine. So if a input is 0, output is 0. Fine. If input is 1, output is also 1. Shall we see that? I'm going online. Yes. So this is online and I'm going to take the simulation box. This is the first channel 8-bit. Okay. So this is the address I have used, right? I0.0. So this is I0.0 and this is Q0.0 where I can see the output. See here, according to our truth table for normally open contact, input is 0, output is 0. Can you see? Input is 0, output is also 0. So now what is the second thing in truth table? Input is 1. What will be the output? Output is also 1. Correct. See, input is 1, output is also 1. Okay. So this is normally open contact. Unless or until you press, it will not give the output. That is normally open contact. See, if I turn off, it will off. Right? See? Like this. It will be working like this. Got it? Yeah. So now, imagine you are having two normally open contact. How you will be connecting? You will be checking whether to connect in nearby or parallel. So just now I'm for time being I'm just connecting in a series. I'm giving some other address. Fine. Let's go for online. So since both are normally open contact, it is 0, 0, 0. Fine. So if I turn on, Up to this power is coming. So I 0.1 is not turned on. No, that's what it is not giving output. If you turn on that, output will be on. Q 0.0 is on. So like this only, you need to use the normally open contact. So unless or you can conclude that unless or until you disturb the switch, it will not give supply. What is the supply I am meaning here? Supply is coming up to this. Fine. It is not crossing this contact. Why? Since normally open contact is not pressed, it is not allowing the supply to entering. Suppose if I press this, imagine I am pressing this. See, once I pressed this, supply is crossed this place. Fine. Now again it is restricted by I 0.1 because I 0.1 is not pressed. Shall we press now? Yeah. After you have pressed, Q 0.0 is on. Correct? Fine. So it is restricting the power supply until or unless it is pressed. Fine. After that it will be allowing. If you want to again, if you press, it will break. See here, if I again break that I 0.1, I am breaking the I 0.1. Now see here again power is restricted up to this. If I turn off I 0.0, again it is restricted. Fine. Yes. So this is normally open contact. Fine. Shall we see the normally closed contact? How it is working? So what is this normally closed contact? Normally closed contact. So it is just opposite to normally open contact. Fine. So if we thought about our truth table for normally closed contact, we are having one input and one output. So there, since I have mentioned it is opposite to normally open contact, what will be the first case of truth table? It is 0, output is 1. When the input is 1, output is 0. Okay. So let me see that in a truth table. Now we are going to see about the normally closed contact. Fine. Yeah. Just a minute. Yes. So fine. So we have discussed this. So I am deleting that. So where is our normally closed contact? Here it is. This one. Right? I am choosing. You can choose from here or in BitLogic also you can see here. This is also here. Okay. So anywhere you can choose. I am choosing from here. You can choose from anywhere. Now this is also asking a question mark. I should give the address. I am giving some address. Fine. So what I have told for the truth table, when this is input, this is output. Okay. When input is 0, output is 1. Second case, when input is 1, output is 0. Shall we run? Yeah. Yes. See here, I have not disturbed the switch. So I just went for run. Correct. I have not pressed the switch. See here. In simulation box also it is not pressed. Correct. But your output is on. So it is 0, 1. Why I am mentioning the input as 0? Because I have not disturbed the state. Fine. So if I disturbed, you can tell that is 1. That means it is silently allowing the current to pass through because the switch structure looks like already the switch is pressed. The switch initial condition is already pressed, kind of. So that it is allowing, see, it is allowing the power to flow in already. Fine. So if I press, what will happen? If you press, already pressed the switch will open the switch, right? So that's what it is going to happen. See, I am going to press I 0.0, which is making the power to restrict. I mean, the switch is restricting the power to flow. So output is not on. Can you see here? It is here up to this only power is flowing. Correct? So suppose, what if I switch off? Can you see? It is again allowing the power to get in. Fine. So this is normally closed contact. You can use two normally closed contact also. So same as normally open contact, I'm putting that in a series. I'm giving some other address. Okay. Let's go for online and check how it is working.